Yeah. Okay. Good morning again, ladies and gentlemen. My name is Freydun Rezanejad. I'm chairing this session with 3 talks. Our first talk is Dr. Rebecca Rooney. Rebecca is an assistant professor in the Department of Biology at the University of Waterloo. Rebecca received her undergrad in environmental science from Carleton University, master in entomology from University of Manitoba, and PhD in ecology from University of Alberta in 2011. As an aquatic ecologist, Rebecca research is on focus of monitoring and assessment of the wetland ecology. And thanks for accepting our invitation. And yeah, we are looking forward to talk.
Great. Can everyone hear me? Is that on? Oh, good. So yeah, I'm going to be talking to you about wetland policy in Alberta. And it probably helps to have a little bit of background. So up until starting in 1993, Alberta began operating under an interim wetland policy. And that interim wetland policy applied only to the white zone. Oh, that doesn't work. What's the laser one? That works. So if you look at this map of Alberta here, the white patches are what we call the white zone or the settled area. And the interim wetland policy applied only to this region. And in this region, the dominant sort of human activity has been historically agriculture. As a consequence of that agriculture, there's a great deal of historic wetland loss. Between 60 and 90% of the wetlands in the white zone have been lost since pre-settlement times. So to try to stem this tide of loss, the province of Alberta released a policy with the goal to sustain the social, economic, and environmental benefits that functioning wetlands provide. Now, although it uses the word benefits and functions, this policy is really an area-based policy. What that means is that it was managing wetlands on the basis of their acreage. So it's sort of analogous to the US no net loss policy, if you're familiar with that. If this is a map of the distribution of wetlands in Canada, and over here we've got Alberta, the idea is that within at least the white zone of the province, there would be no change in the total amount of wetland over time. But that's not to say that there would be no movement of wetlands around the landscape. And so they had this framework where if you were a developer and you wanted to drain a wetland and build a subdivision, for example, then you would submit a proposal. And the government would initially try to get you to avoid impacting on a wetland. They'd try to get you to move your plan to somewhere else or redesign it so you avoided the wetland. If you could not avoid the wetland, if the impacts on wetlands were unavoidable, then they'd ask you to minimize and compensate for any impacts that did occur. If you were able to compensate nearby on the same site, for example, then they would ask you for every, say, hectare of wetland that you destroyed, you would have to build between 1 and 3 hectares of wetlands to compensate for that destruction. But if you went off-site, then you would be expected to use a higher compensation ratio, so between 3 and 10 hectares for every hectare that was destroyed. Unfortunately, when we evaluate how well this policy has been implemented, we see that this whole avoidance and minimization series of steps are skipped, and developers are going straight to compensation. The regulators in Alberta are not able to say, no, you can't develop. So they go straight to compensation, and most compensation is actually happening off-site. So this is a figure work that was done by Sherry Clare and Naomi Krogman, and it's showing the distribution of wetland impact sites in the different sub-watersheds within the province. You can see this one here. This is Beaver Hills subwatershed. It's right on the edge of the city of Edmonton, a growing urban center. So no big surprise that between 1999 and 2000, there were over 30 different wetlands impacted in that subwatershed. But if we look at where restoration is taking place in the form of compensation for those disturbances, they're not happening in the same sub-watershed. And they actually called this the Camrose solution, because what's happening is development in the city of Edmonton is being compensated for around Camrose, where property values are somewhat less. And if we look at, so this is a natural wetland, and one of its distinguishing features is this zone here. We call this the wet meadow zone. It's dominated by sedges, and it's really important for a variety of biological groups. But if we compare kind of a natural looking wetland with some of these constructed wetlands, they look really different. So that kind of begs the question, are these constructed wetlands actually serving the same purpose? Are they functionally equivalent to the wetlands that they're supposed to be compensating for? In other words, should they be considered adequate compensation? So to try to get at this, our research group, working in the Beaver Hills subwatershed, so here's the city of Edmonton, we looked at 5 categories of wetlands. We looked at wetlands in parks and protected areas, and we called these reference wetlands. They're relatively undisturbed. We looked at naturally occurring wetlands that were impacted by agriculture. We looked at restored wetlands and constructed wetlands. And when we examined 45 different environmental variables at each of these wetlands, some patterns emerge. So here's reference wetlands clustering pretty nearby where the agricultural wetlands cluster. One of the main discriminating factors between reference and agricultural wetlands is nutrients, unsurprisingly. But if we look where the restored wetlands and the constructed wetlands end up clustering, you can see that they're quite distinct in terms of the environmental stresses they face, their physical structure, all these variables that we measured. So they're environmentally distinct. They're also biologically very dissimilar to natural wetlands. So we looked at the 6 most commonly evaluated bioindicator groups in this type of wetland, and we found that in each case, the community composition of constructed wetlands was totally distinct from what we saw in naturally occurring wetlands. So we've got these constructed wetlands. They are distinct in terms of their environmental stress variables. They have altered hydrology, altered physical structure, distinct biological communities, and we measured their biotic integrity and floristic quality, and it was also lower. So basically, no matter which way we looked at it, these constructed wetlands they're not resembling natural wetlands. So this interim area-based policy, it had some problems. We were going straight to compensation, skipping that avoidance step. So we were failing to protect natural wetlands. And we were favoring off-site compensation. So we were moving wetlands from areas where there was high property values, and we were shifting them across the landscape to areas where property values were lower. And I think most importantly, in my mind anyway, these constructed wetlands are so dissimilar from natural wetlands that they're not really providing the same wetland functions or values that they're meant to compensate for. So sort of the moral of the story is that if what you want to do is protect wetland values, then you need to measure them and manage on that basis. So what are the wetland values that people care about? In Alberta, the Alberta Water Council led all these sort of stakeholder consultations and came up with this real collage of different things that people think are valuable when it comes to wetlands. And then it fell to the wetland policy team and some expert working groups to try to categorize those and lump them into some kind of umbrella categories. So they distilled it down to 4 major, what they call relative wetland values: biodiversity and ecological health, water quality improvement, hydrologic function, and human use. Now, human use is including cultural values, recreation, education. So all of the different values that Albertans indicated were important to them are kind of encompassed in these 4 categories. And presumably, if we can measure them, then we can start to do things like protect wetlands of the highest quality that are the most valuable, conserve and restore wetlands and their benefits. And rather than just replacing lost area when developments occur, we can actually start to replace lost value. But to do this, we need to be able to measure them, and we need to be able to measure them each independently and then integrate them in some way to come up with a score which would serve as the basis for example, determining overall value. And so this is what the new wetland policy aimed to do, and it was released September of last year with some pretty tight timelines for implementation. They want to have it implemented in the white zone, which I showed you, by this August, and then in the green zone, which is pretty much the rest of the province, the following August. Its goal is pretty much unchanged from the interim wetland policy that was released in 1993, but it now applies to the entire province. It still follows this avoid, minimize, replace framework, but now instead of doing that on the basis of wetland acreage, we're doing it on lost value. So, and they're called relative wetland values because they're being measured relative to historic losses in these relative assessment units. So you start to get some big acronyms. I'm going to try not to use any of them. But these are basically units that are delineated on the basis of their watershed boundaries as well as ecoregional boundaries. So they're distinct in terms of climate, in terms of vegetation communities, soil characteristics, as well as watershed boundaries. And so if we're able to measure these 4 relative wetland values within each of these assessment units, then we can start to compare wetlands in terms of the values they provide to wetlands of a similar type or to other wetlands in the same region. And this allows us to prioritize different values at a regional scale based on historic loss, what we can consider sort of functional deficits. So if you live kind of near Calgary, you probably heard in the news there was a lot of flooding there last year, then you might prioritize hydrologic function and try to maximize wetland restoration that will improve surface storage capacity. But if you live in an agricultural district where you have historic problems with toxic algae blooms, then you're probably going to focus on water quality improvement. And so this approach allows regions to prioritize what functions or values are most important to meet their regional needs. But to do this, we need to be able to measure historic loss. And to be honest, we don't have a very good record. We don't have a great drained wetland inventory for the whole province. So this was a real challenge to implementation. And Dr. Irina Creed at the University of Western came up with a very creative approach to solving it, inspired by Zhang et al. And work that that team was doing in the Prairie Pothole region, where they found this power law relationship between the area of a wetland and how common that sized wetland is on the landscape. And if we look in Alberta, we see the same trend. So it doesn't matter if you're up in the Uticuma subwatershed, down here in the Beaver Hills, or down in Rocky View. Of course, there's differences in the total amount of wetland, but when we look at the frequency distribution, it's the same pretty much any watershed you look at. So because we have this power law relationship, and because of this tendency that the wetlands that get destroyed first are the smaller wetlands, we can use deviations from this theoretical relationship to estimate how much loss has occurred. You might have moderate loss in one assessment unit and major loss in another. But this gives us a baseline to estimate how much loss has occurred and then use that to try to weight, sort of like you could imagine a volume knob being turned up and down, depending on historic losses of these different values, so that we can relatively weight them to sum them together to get some kind of grade. Now this wetland replacement matrix comes straight from the government of Alberta. And what it's essentially indicating is that if you are a developer and you want to turn this wetland into this subdivision, and this wetland gets a grade of a B, then if you compensate for its destruction by building wetlands that get a score of D, you're going to have to build 4 hectares for every 1 hectare you destroy. But if you can build something better, if you can build something that scores a C, you only need to do 2 to 1. And if you can, by some miracle, build an A, then you're down to less than a 1-to-1 ratio. So this is theoretically how it's going to work. And if it does, then we're going to start enabling avoidance, because no developer is going to want to build on an A if it's going to potentially cost them an 8-to-1 area ratio. And it's also going to encourage investment in restoration and construction design to improve the quality of these constructed wetlands. So the wetlands that I evaluated, most of them were constructed over a decade ago, and I showed you they were of inferior quality. But using science and using engineering, we can start to design ones that function better. And this is going to provide incentive to do that. And it's going to allow us to manage wetlands on a regional basis in light of historic loss and this kind of concept of functional deficits. But we're sort of asking this system to serve too many masters. In a sense, we want it to be able to provide provincial level accounting so the government can report on how well it's doing at managing wetland function. We also want it to serve in terms of regional or municipal level planning. We want it to be the basis for individual project approvals, and then we also want to use it to try to monitor the compliance of restoration agents and make sure if they say they're building a C, it turns out to be a C. So we basically need something that can span this huge gradient in scales. And with over 10 million wetlands mapped in Alberta, and the implementation deadline of this August or next August for the green zone, there's no way that we're going to be able to go visit each one of these and measure it on the ground. So we need to turn to satellites. We need to turn to GIS-based assessment. And the reason we want to do this is we want to develop a map that will plot the relative wetland values for each wetland in the entire province. And that will provide an amazing tool. If we have this tool, then developers will have some ability to do some upfront work. So if they're looking at developing in a certain region, they can pull up this online map and see what the value of wetlands are on it and know in advance that it's going to be a really expensive place to work. So they can modify their plans on that basis. And in terms of regional municipal planning, it's going to be fantastic. We can identify where to conserve, where to build new parks. We can prioritize restoration activities. And, but the issue is it all needs to be done with available geospatial data because the timelines are so tight, it has to happen right now. So again, Dr. Creed has been doing some really innovative work on this, and she's managed to come up with, using existing geospatial data, different metrics that fit within these 4 relative wetland value categories. Hydrologic function, ecological health, water quality, and human use. And so these metrics are all things that she can measure using satellite imagery, remote sensing imagery, LiDAR, radar, Landsat. So I only have time to really go into one example, but this is how she's able to measure subsurface storage potential. So this is, again, the Beaver Hills subwatershed. And what she's showing is that using the thermal band from winter scenes of Landsat imagery, you can identify discharge zones because in the winter, where you have groundwater discharging, it tends to be warmer than the surrounding land. And so she's been able to use this to map all of the discharge zones in this entire subwatershed. So we can ramp this up to the entire province and start to get a handle on subsurface storage potential. She combines that with measures of synchronicity, surface storage, connectivity, and other metrics to produce maps like these. And this is showing a sort of net or integrated assessment of hydrologic function across the entire subwatershed. So you can identify places that need conservation, places that need restoration. But if you're thinking about individual project approvals, we want the burden of proof to be on the proponent's shoulders, not the government's. And so we also need an on-site assessment, something that goes hand in hand with the GIS-based assessment. And because it's going to be implemented by consultants, and you want one consultant to go out and find the same thing that the last consultant did, it needs to be rapid, reliable, and repeatable. It needs to provide a relative wetland value score for each of the 4 values, and then a final score which will feed into these decisions about compensation ratios. So the tool that we're sort of adopting for this purpose was developed by Dr. Paul Adamus down at Oregon State University, and it's called the Wetland Ecosystem Services Protocol for Alberta, or WESPAB for short. And it's a rapid assessment method that essentially answers 134 questions in a 1 to 3 hour long site visit. Basically, some observer heads into the field, Tilly had optional, and takes a bunch of observations that feed into this matrix of weighted ecological characteristics. And this matrix then becomes the input for logic-based models that are derived from literature as well as expert opinion, and that those models output estimates of 14 wetland functions. So this whole system has been peer-reviewed repeatedly. It hasn't really been validated, but I'll talk about that later. And it's undergone repeatability testing for the prairie region, and this summer it's going to be expanded up into the parkland. So these are the 14 functions that it measures, and if you just start to scan through them, you see that they group into these 3 of our 4 wetland relative value categories. Hydrologic function, there's a lot of water quality functions, and then many biodiversity and ecological health functions. So it seems to be missing human use, but actually a lot of the ancillary data when you collect this that you get while you're out in the field feeds into this concept of human use value. So you get estimates of local population density, accessibility, the presence of trails, proximity to schools or parks, or the existence of different registered research sites or interpretive centers. And so this gives you a handle on some of the recreation, cultural, educational values that that wetland's providing as well. So it can be used to address all 4 of our relative wetland values. But one of the issues with measuring wetland function is that it's the healthy wetlands that are providing function. So we also need to make sure that wetlands that are being constructed are truly healthy. And to do this, we may have different relationships between the level of health and the level of function. It might be a linear relationship. You might expect there'd be some kind of threshold or even some kind of asymptotic relationship. But either way, health depends on function, or function depends on health, I mean to say. So if we're going to be doing compliance monitoring, then what we want to measure isn't just the provision of those functions, it's the actual health of the system. So to measure health, it requires a somewhat more intensive approach. And we've developed a system that does this using the reference condition approach. This is an example of one of the tools we've developed. It's a plant-based index of biological integrity. And so this was done in the Beaver Hills subwatershed. Hopefully you remember these bright colored symbols. And what this is showing is that this green cloud here represents the natural range of variability. Basically, natural sites can be kind of anywhere in there and still be relatively healthy. So we call this the reference condition. And if a restored site falls within it, then we would decide that restored site is healthy. But if we have sites that are lying far outside of that region, out of that zone of variability, then we conclude they're unhealthy. So they're less likely to be providing the functions that we value. And we've developed IBIs in different places for different types of wetlands, but they are specific to the type of wetland. If you're looking at a marsh or a fen or a bog, they're also specific to the ecoregion in which you're working. So we've developed so far ones that evaluate permanent marshes in the boreal and the parkland regions. And this summer we're going to start developing ones that assess seasonal marshes in the parkland and the grassland. But more work needs to be done to get coverage for the whole province. So we've got these kind of starting points. We've got some means of a GIS-based assessment using existing data, some on-site assessment, and these indices of biological integrity that can start to measure wetland health. And so we span this sort of gradient from broad spatial extents, long-term, greater uncertainty, down to really fine scale but much more expensive to implement, responsive and less uncertainty. But we want these things to be repeatable, we want them to agree, and we need them to be accurate. So in terms of repeatability, if you go out and estimate using the on-site assessment, for example, water quality improvement or any of these functions, you want those estimates to be consistent if you go back the next year or the next year. You want them to be consistent if you're looking in the boreal versus looking in the parkland. And you want them to be consistent whether you or your buddy are taking the observations. So some of that assessment has gone on, as I said, in the grassland or the prairie region, but it needs to be expanded. We also want these things to agree, at least on the final grade, even if the exact 4 relative wetland values are a little different. You can imagine how upset a developer would be if they went to that handy-dandy online map and found a wetland got a score of C, and then when they went and did their on-site assessment, it scored an A. So we want these things to be in agreement. And that assessment is ongoing now. And then finally, we want them to be accurate, and this is what we haven't yet done. Presumably, there's some real level of water quality improvement value or hydrologic function. How much time do I have? 2 minutes. OK, good. We're going to make it. So the on-site assessment and the GIS-based assessment, we want to make sure that they're reflecting those real values. And that requires validation through direct measurement of those ecosystem functions and comparison to the estimates that these models generate. So that still needs to happen, and that's going to be quite a long-term project. But so to summarize, we've got our area-based policy that failed to measure or manage wetlands in terms of their function, that produced compensation wetlands that were inferior in quality, and high-value wetlands were essentially being destroyed and replaced with these inferior constructed wetlands. In contrast, a function-based policy gives us the opportunity to balance lost wetland values with the quality of the compensation wetlands that are constructed. It also encourages us to avoid high-value wetlands, and it supports development of improvement in our construction and design technology. And it's going to reward that with real financial incentives. It also allows us, because of this measurement of historic loss, to estimate functional deficits on a regional basis and account for regional needs and priorities. But there are some dangers. The system is quite complex. It's hard to implement. It's a bit unwieldy. There's some subjectivity in measuring function, whereas area was quite straightforward to measure. As I mentioned, there's not been much validation yet, so there's concerns over accuracy. We don't have province-wide coverage yet, although we're moving in that direction. And again, the government, this is a new tool for them, so they don't have the expertise in implementing it yet. We don't have a data management system to handle all this data we're going to be generating about wetland functions. And the timelines are short. So I guess I'll try to end on a positive note, and I'll say I think this new wetland policy is a move in the right direction. And fortunately, it's embraced this sort of philosophy of continual improvement. So hopefully it will keep on moving in the right direction. And I'll just conclude by thanking all of the many collaborators who've assisted and the many field and lab assistants, as well as our funding sources. And that's it.
Thanks, Rebecca. Okay.
I don't have time for questions.
It's okay. It's a great talk. Okay, we can have one or two questions for Rebecca. Yeah?
Yeah.
Yeah, so does the new system still have that issue with location where people can move locations?
Yeah, so the location of compensation will probably continue to be off-site, and that's not something they can change very easily.
Yeah, Jenna.
I'm just wondering, in the ratios, when you had, if you destroy a B, you make a C at 4:1, if the cost of making those wetlands went into how those ratios were set. If you can make 10 hectares of D for cheaper than you can make 1 hectare of A, what's your motivation?
I think that we have never yet made an A, so we really don't have a handle on what those costs would be. But I think the goal was to provide some leverage, because right now there's nothing. There's no incentive to try to reach above and beyond.
Okay, we can have one more question if anyone. Yeah.
Nice talk, Becca. Quick question. So when you talk about these 4 different functions and a wetland is restored, how can you be so sure that restoring one moving in a positive direction would mean all the others would move in a positive direction? Just as an example, if flood water storage was my objective, right, I would want big water bodies. But that would be terrible for biodiversity. So how would I weigh these factors as to what I want?
Yeah.
Create a final score.
So essentially the idea is that that's where that estimates of historic loss are going to come in and help to arrive at functional deficits in different regions. But it'll also be a sort of social political decision, right? If you're in Calgary, you're going to prioritize flooding even if you risk losing biodiversity. And we do find that there are trade-offs, definitely. So those relative wetland values, they don't all go up together or all go down together. Certain types of wetlands are better at providing some than others. So that's why it's important to retain them as separate measures and then combine them with regionally specific weightings.
Okay, thank you.
Yeah.
Good. Yeah. Thanks again.
Thank you so much. It was a pleasure.